Course 2, Lesson 18. We are going to be on page 120. And today we're going to be talking about a polygon and what that means as far as a shape is concerned. Um, Polygons have basically four sides, okay, and they are all connected. All right, and we're going to look at different shapes that we can make. And a polygon simply has to be more than two sides, okay? So it can't be this, but it can be this, or put as many more sides as you want to. We can make polygons all day long. And then the difference between similar and congruent, and I'll give you just a quick idea here. If I make a triangle and make the exact same triangle, these would be equal and congruent. We're going to look at let me blow this up. It's an equal sign, and then it is a little curved symbol that would say that they're equal and congruent, which means they're the same. Similar would mean that I have a large one and a smaller scale one. They're similar, but they're not congruent, okay, which means they're not equal. This may have a value of 5, this may have a 2. Okay, so they're similar, but they're not congruent. Anyway, let's get to the lesson. Okay, on what is that? 121. You're going to see a box, and it's going to give you names of polygons. Okay. Names of polygons, we're only going to go up to 12. So you'll notice that there is nothing for 1 and there is nothing for 2. And the reason is because if you only have one side, you have a line. If you have two sides, you have two lines, or you do have an intersection. But notice we start with 3, where we have 3 sides that connect. Poly means more than 2. Or you could say it this way, 3 or more sides. Okay? So there's an infinite number of polygons because we can do a shape that literally has a ton of sides, and we can make it as many sided as we want as long as it connects back again. Okay, that was a bad polygon, but you get the idea. So triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, undecagon, dodecagon. Those are the terms that you will see as far as that is concerned. Now, in your textbook, you've got a shape that looks kind of like this, and they give each intersection an actual value. All right, so we can name this polygon, and if we go, we're going to call this a U. I'm going to put this a little bit, and this a V. Okay, we're going to go clockwise, and we're going to start over here. And if we did clockwise going all the way around, we could name this U, S, T, V. We could go the opposite way and say U, V, T, S. And if we started with this one and went clockwise, so you can understand that we could get 4 different names and 4 different counter names because of that. Pretty simple, as you can see that in 121. Now, there is a regular triangle. On the next page, you're going to see a regular triangle is something that has similar sides. Then there's an irregular triangle. We're going to call that scaling, which means that all 3 sides are different. Okay, there is a square. We would call that a quadrilateral. And then there's one that looks like this. Okay, or whatever shape you want to do it, where none of the sides are equal. different lengths. There's a pentagon, okay? Pentagon has 5 sides, right? And then there's an irregular pentagon, which you would make a shape that has 5 different sides. And then anyway, all that's showing you is that it can be all kinds of different shapes, okay? All right, let's look at example 1. Example 1 has a shape that looks kind of like an upside down, or it looks like this diamond shape almost, okay? It says name the polygon, and is the polygon regular or irregular? Well, you'll notice that these two lines are longer than these. So I'm going to give these two tick marks showing that this line and this line are longer. So I'm going to call that irregular, okay? And I'm also going to count the sides. 1, 2, 3, 4, 5. So there are 5 sides, so I know it's a pentagon, okay? And I would say irregular because if it's a regular pentagon, all sides are equal, okay? In this one, this side right here and this side right here are longer than these 3. So it's an irregular pentagon. Pretty easy, okay? Just naming shapes, right? Okay, the next part of your lesson deals with this similar and congruent, okay? So if I have a line and I call this A and I call this B, and I have another line that's exactly the same and I say C and D, okay? Let's make sure that you understand that I'm trying to show you an exact copy of this line. So line AB, right, is equal to and congruent to line CD. This symbol right here says that line AB is equal to and congruent. The word congruent means exactly the same, okay? If I have another line and I make EF over here, I can not say, or I can say that line AB is not equal or congruent to EF. And the reason is because obviously it's shorter. Okay, there's no doubt that it is shorter. So it is similar to, but there is no symbol to show similarity. Okay, let's look at triangles for a second. Okay, if I made this right triangle, okay, and I made this right triangle, pretend that they're totally equal, okay? Maybe I can redo that a little bit better. There, that's a little bit better, okay? Call this triangle A, B. Triangle A is equal to and congruent to triangle B, okay? If I did A like this again, call this A, and I did this as B, triangle A is not equal or congruent to triangle B. It's similar. And the reason it's similar is because it has similar features. In fact, if I were to take this one and transpose it and put it into this triangle, it would fit right in that spot. Okay, let me highlight where I could add this triangle. If you can put it in and it fits exactly the lines and the dimensions, then it's known as similar. Okay, just the math language that you're learning. Okay, and I think you're going to find this pretty easy. All right, I want you to look at example 4 on page 124, and you're going to get 2 different triangles. Okay, this is one, and then they give you this one. Okay, they name the Z or X, Y, Z, right? and then we have A, B, C. Okay, what are we doing with these triangles? Okay, the question A says, which triangle or which angle in triangle XYZ corresponds to angle A in ABC? Well, angle A is here, and you notice that this angle right here is the hypotenuse. In other words, it's the ramp. It's the same as this one right here. So we would note that this angle and this angle are the same. So angle A is equal to and congruent to angle X. All right, and how we say angle is just to put that symbol before whatever we're guessing. Okay, all right, so angle X has to be the answer. Then it says B, which side in triangle XYZ corresponds to BC? All right, let's get a different color here. What is BC? BC is this hypotenuse right here, which is the same as this one right here. So line A, or excuse me, line BC is equal to and congruent to line YZ. That would be our answer. Okay, just like this is our answer. All right, I think you can see this pretty easily. Pretty simple lesson, and if you have questions, be sure to ask.